In sections 3 and 4 of chapter 2, we're going to work with a lot of applied problems. So let's get started in section 3. We've been solving linear equations, and we've also had some practice turning words into expressions. Example 1 combines those two skills together in this type of problem solving. Part A says that 3 less than 4 times a number is 29. Let's first work on writing an expression that represents 3 less than 4 times a number. Now, when you see the words a number, that's your clue to choose a variable. Let's choose x. We need 3 less than 4 times our x. We need 4 times our x, but then we need 3 less than that. So we can write 4x minus 3 to mean 3 less than 4 times a number. When you see the word is, that's your clue for your equal sign. So we can now write equals 29. Now we're just left to solve for x. I'll first add the 3 to both sides of the equation. This leaves me with 4x equal to 32. Dividing both sides by 4, we are left with x equals 8. I'll let you plug that 8 back in to make sure that it works and also practice with part B. Sometimes in our problem solving, we need some extra formulas and definitions that we borrow from the geometry side of math. Let's write down a few of those so that we have them at the ready when we need them. Let's start with a square and a rectangle. Rectangles have two different types of sides. They have 2 length sides and 2 width sides. Squares, on the other hand, all 4 sides are the same length, so we can just label all 4 sides same variable s. The perimeter of a square, that's the length all the way around, is s plus s plus s plus s, or 4 times s. The perimeter of a rectangle would be width plus length plus width plus length. Picture yourself starting in one corner and walking all the way around the perimeter. This simplifies to 2 times w plus 2 times l. That is 2 widths and 2 lengths. Now let's talk about area. I'll start with the rectangle. The area of a rectangle is length times width. For a square, it's the same, length times width, except for in a square, the length is the same as the width, s times s, or s squared. Now let's talk about triangles. Let's label the 3 sides of the triangle S1, S2, and S3 for side 1, side 2, and side 3. The perimeter of a triangle, that would be the length all the way around the edges, would be the sum of the 3 sides, S1 plus S2 plus S3. The area is calculated a little differently. Area, you may remember, is 1/2 times the base times the height. That is, if you have a height of your triangle of length h, and your base of your triangle has some length b, then the area is 1/2 times that base times the height. There's 2 types of special triangles that we may run into: an equilateral triangle and an isosceles triangle. With an equilateral triangles, we have 3 equal sides. With an isosceles triangle, we have at least 2 equal sides. So if you run into an example that mentions an equilateral triangle or an isosceles triangle, make sure that you label 2 or 3 sides with the same length appropriately. Lastly, let's remind ourselves about circles. If we have some circle with radius r, the perimeter of that circle we call the circumference of the circle, and that's equal to 2 times pi times the radius. The area of the circle is equal to pi r squared, or pi times the radius squared. And now you have some formulas and definitions from geometry that you can use to help out with solving some problems. Let's take a look at example 2. Example 2 tells us that we have a rectangular living room with a perimeter of 80 feet. Let's draw the picture and jot that down. Since the living room is a rectangle, we have some length and some width. We're also told that the perimeter is equal to 80 feet. That is, 2 times the length plus 2 times the width is equal to 80. Let's keep reading. The length of the room is 8 feet less than twice the width of the room. So let's write that down. The length of the room, L, is 8 feet less, so we're going to subtract 8, than twice the width. Okay, so 8 less than twice the width. So L is equal to 2 times W minus 8. Now we need to find the dimensions of the room. We need to take this information to solve for L and to solve for W. In our equation for the perimeter, we can't solve for L and W because we have 2 variables instead of 1. What we can do is take what we know about the length and substitute it into our equation. If we know that L is equal to 2W minus 8, we can substitute 2W minus 8 where the L is. Now we only have 1 variable in our equation and we can solve for it. Distributing the 2 into the parentheses, we have 2 times 2W, or 4W, and 2 times negative 8, or negative 16. We still have our plus 2W. Now we can combine like terms. We have a 4W and a 2W combined to make 6W. So we have 6W minus 16 equals 80. To isolate that W, we'll add 16 to both sides of our equation. This gives us 6W equal to 96. Finally, dividing both sides by 6, we've isolated the W and we have W equals 48. Now we know the width of the rectangle. It's 48 feet. Now we're just left to find the length. Remember, we have that the length is equal to 2 times the width minus 8. We know that the width is 48, so we can substitute that in and solve for L. This gives us that the length is equal to 96 minus 8, or 88. That is, the width is 48 feet and the length is 88 feet. We've solved the problem. I will leave part B of example 2 for you, and I'll move on to example 3. In example 3, these are problems involving triangles. I will move on to part B, leaving A for you. The first thing we read in part B is that we have an isosceles triangle. So let's stop right there and draw it. Remember, the special thing about isosceles triangles is that 2 sides are the same. And the way that I have drawn this, I have these 2 sides of equal length. The third side I'll label Y. Let's keep reading. An isosceles triangle has a perimeter of 48 inches. That is, the perimeter of this triangle is 48 inches, or x plus y is 48 inches. Let's keep reading. The longest side is 6 inches longer than each of the sides that have equal length. That is, this longest side down here is 6 inches more than the other 2 sides, or x plus 6 inches. Now that we know that y is x plus 6 inches, we can substitute that in for y. Now we have x plus x plus x plus 6 equals 48 inches. Simplifying on the left side, that's 3x plus 6 equals 48 inches. Subtracting 6 inches from both sides, We have 3x equals 42 inches. Dividing both sides by 3, that's x equal to 14 inches. Now we know that these two sides of the triangle are equal to 14 inches. We also know that this third side is x plus 6, or 14 inches plus another 6 inches, for a total of 20 inches. We now have the length of the three sides. Let's take a quick look at example 4. If you've ever taken a friend and gone a long distance in a car, you might be able to relate to this example. Here we have Jake driving at a rate of 85 miles an hour for a certain amount of time. I don't recommend driving that fast, but here we are. His brother Elwood then took over as the driver. Elwood drove at a rate of 90 miles an hour for 3 hours longer than Jake had driven. If the two brothers drove a total of 970 miles, how long did Elwood drive? Let's first write our equation in words, and then we'll fill it in with numbers. First, we have Jake that drove a certain distance. Then we had Elwood drive a certain distance. We also are given a total distance for the two of them. Let's fill in what we know. Right away, we know that the brothers drove a total of 970 miles. We know that Jake drove 85 miles per hour for a certain amount of time. We don't know what that amount of time is, so let's use t. To find out Jake's distance, we would take 85 miles per hour, multiply that by the number of hours he drove, and that would be his distance. Same for Elwood. Elwood drove 90 miles an hour for 3 hours longer than Jake. So if Jake drove for t hours, Elwood drove for t plus 3 hours. And now we have an equation that we can solve. Let's start by distributing the 90 to the t and the 3. 90 times t is 90t, and 90 times 3 is 270. This gives us 85t plus 90t plus 270 is 970. Combining like terms, we have 85t plus another 90t for a total of 175 times t. We can now begin to isolate t by first subtracting the constant 270 from both sides. This will give us 175t on the left and 700 on the right. Finally, dividing both sides by 175, we have t is equal to 4. Now we know that Jake's amount of time driving was 4 hours. The question asks us to find how long Elwood was driving. Well, Elwood, we know, was driving 3 hours longer than Jake. 3 hours more than Jake would be 7 hours. And we've solved that problem. And that is the end of this section.